Hello guys, I'm just trying to show what exactly we have now. So for example, this is an image in my room, and then you have some video that I'm taking. So for example, in the next frame it gets rotated, our camera. So is there some way we can correct these things? So that's what I'm trying to show here in this algorithm implemented to do that. Okay, so you can see is the frame which you can see the one is image on the left, that is the actual source image. I mean, it is vertical upright, and here is something that is rotated. So I created a synthetic thing to just show here wherein it is rotated. So what we want eventually is this is this is the actual frame, and then the one that was rotated here should be get corrected like this. And this black region that you see, that will happen because we don't know some of the information here. So we don't know what to fill here, so that's why we will get these kind of a black areas. But that's not a problem. The main idea is to have these kind of, so if you in your frames, so your camera, for example, its stable position is this one, and then your camera goes on rotating something like this. We can correct that using this kind of algorithm if we know how to rotate the this to the canonical position, that is this one. Okay, so what is the first step that we do? First step that we do is to detect a corners in an image. For example, here it is shown. So we detect some very suitable corners, because the corners are required, because if you take this one, this particular region, it can match to any region in here. So it's not very stable if we take these points as as the points, so that we can use that point to rotate, but we instead use the corners. So for example, in this is Prachi's specs. Here you can see there is a corner here, and then there is a corresponding corner in the frame that is rotated here. So basically we are going to, so you can think like you are going to drag this point and bring it somewhere at the position which is here. If you do the same thing with some texture points here and here, we can't find the correspondence so that we can drag. But if we stick on to these corners, we can drag this thing to come at this position. So we can find how much this image is rotated with respect to this using all these corner points, all these corner points. Okay, so I think you guys got what exactly is the corner point. So the next step is finding the correspondence. So I know here a set of points here which are corners, I know here a set of points which are corners, but I have to find the correspondence, right? So I want to pull this one to at this position. So I have to first know if this one is connected to this one, and this one is belongs to this one. So that's what is needed. Next step. Past video we saw how we detect these, why is it important to detect the corners. There is some algorithm which I have used to detect this corners. So once we know the corners, as told, we need a correspondence. Okay, so for that I have used some algorithm. So here are the set of correspondences. One second. Yeah, so I had some algorithm which can detect this correspondence. So for example here, so the here are some corners. For example, this one corresponds now to this one. So you see, it's quite good. So these are in-layer correspondence. I mean, I know the algorithm. I use some algorithm which can find, I mean, a lot of correspondences, but there is a algorithm called ransack which can detect the in-layer correspondences. In-layer means these are something valid correspondences. and that ransack filters out some outlier correspondences. For example, here, so you can see this one was detected as something else. So these were all removed using these wrong outlier correspondences were removed. So, so basically, to find this correspondence, in summary, we need two things. The first thing is first to some algorithm to first find the correspondences, which can include these inliers and outliers. And the second thing is a ransack, which can filter out these inlier correspondences, which we can then use to drag these points at this position. So in the next thing, I will show you how how using these correspondences that are in inlier, when I correct the destination image, it looks something like this, which is this was earlier, how it was looking, and this is the destination. So I think you got an idea. So this I can, if I can do it with the two frames, I can do it with the successive frames as well. And also I can smooth the set of all these rotations, and I can make the video stabilization for all the frames within the video. This is just for two frames that I have shown you on. Thanks. Okay guys, here I have is one more example wherein I unzoom the image. So in the left part, if you see, so this is one image, and then which I have taken, and then there is a corresponding image wherein I just zoom, I mean I go closer to the object and take the photo. So I want to undo this thing. So undo in the sense the algorithm should know how to scale this particular image to this particular part. In the earlier video, we saw rotation and translation in action. Here is to show the scaling in action. So undo the scaling. So this is, maybe you can see sometimes some scale time version of this one. So here is the destination. How does it look after all the after running the algorithm? So you see, this is the input image, and this one was, we do it, the algorithm unzooms it to match this destination, I mean the source frame. So here is how it looks. So you see, both are at the same scale compared to here. And here are some corner points that are detected while performing this, which we require, as we already see. So here are some corner points from the smaller image to the bigger scale. Here are some inlier correspondences. How does it look? You see, even if, at the bigger scale, the point correspondences are quite good. So here are some outlier correspondences. These are wrong correspondences which are filtered out by ransack. And then this is the final result. Uh, Hello guys, here is the shaky video. I'll just run for 10 seconds, and I have just run it for 10 seconds. It's quite fast as well, but you can see it's quite shaky to see, but here you can see it's quite stable. It's a stabilized video. Okay, here is the case for the zooming case. Okay, so I zoom in this, there is a distortion in form of a zoom. Okay, if I want to remove that, here is the stabilized.